And then here is the attendance. I think the number of the day is 21, which is the day of today's date. So 21, 21. Okay, I'm just gonna move on. So we're gonna start off with some announcements. So the hack challenge is coming soon. The hack challenge is coming soon. I think in like after next 2 weeks. This date is wrong. We have to update it, but it's coming. And the upcoming topics, I think next week we're gonna cover fragments, and then the week after that is persistent data storage. And this week we're having a mid-semester feedback form. We'll release it with the homework. I mean, we're kind of a little bit past the midpoint for this class, I think. Yeah, it's like the 4th week, so we kind of just passed the midpoint, but we still want to get some feedback from you guys to see how you guys are doing in the course. If you have any feedback for us, that's the place to say. And the drop deadline is 4/13. I think the ad deadline is this Wednesday, if I recall correctly. So if you aren't on CMS or if you aren't added, it's a little bit late, but we can try and accommodate you. So just email us, reach out to us, and we will let you know if you are at risk in terms of grading wise. I think most of you should be fine, but yeah, we'll release that more formally, I guess. And then just talk to us if you have any questions or worries. You know our emails, or you can hit us up on a discussion. So yeah. And here's just a review of what we talked about last time. We went a little bit over the Android lifecycle, and we went over intents, like the implicit intents, which is sending data between apps, and then the explicit intents, which is sending data within apps, like switching between activities. We use explicit intents for that. And we also talked a little bit about the manifest, which is where activities are declared. It's also where you have to declare permissions in the first place. And then we also talked about permissions, normal and dangerous. You also had a little bit of exposure with that. I think the location permissions in the homework. So hopefully that should be familiar. Yeah, as I said, today we're going to be talking about ListViews and RecyclerViews. So I'm going to introduce kind of the start of that with some examples. So here's just an example of 3 apps I have here. I have Facebook, Podbean, and Venmo. So lists are probably one of the most like ubiquitous layouts that can be found in any mobile app. All the screenshots above kind of show different usages of lists like layouts. For example, in Facebook, you kind of see like the lists are used to display each post in the newsfeed here. So you see the first post is like a post from MIT. And in Podbean, each cell on the list is clickable, and it leads the user to a specific podcast page. Each row has like information about what podcast you might be wanting to listen to. And in Venmo, it kind of has like it's used as like a transaction history. And you can like click and like on things. You can like have some input controls. So how can we build similar lists like this in Android? And with that, we introduce 2 kinds of views: ListView and the RecyclerView. First, we'll talk about the ListView. So ListViews are used for when the list is not expected to extend past the screen, or when individual cells in the list have simple layouts, like just a text view. So here's kind of like an explicit example of a list view. So this is our app eatery, and here's like an example of a list view. It's kind of just used to display the different menu items that we have. For example, this is the menu items for brunch for Becker House Dining. So simply used to display each item offered by said eatery, in this case Becker. And each of these items are considered cells, like each of these individual rows are considered cells. They're all like one piece of data. The list view is just a collection of cells which comprise our data received from our backend to craft these different lists. List views are limiting in the sense that they don't extend much past what you see here. They're used for very, very simple layouts. Yeah. And here's just a brief overview of like how you can implement a list view. We're gonna be getting more into this later in the demo, but yes, you start off by like putting things in a list, and then you create an adapter which ties the list view to your adapter and helps populate it. Yeah, more on this in the demo later. And I kind of want to warn against using list views. List views aren't really used in industry. Industry tends to shy away from using list views due to the slow performance. List views have a habit of creating as many rows as there are data items in your data set. So if you have a lot of text that you want to display, a list view will literally create all rows of those said text, which can be a costly affair to have to display this long list. It can also lead to lag because you have to scroll through everything, which can make a lot of lag for the user. And list views are also limiting in the sense that they can only be used to scroll vertically, like up and down, and you can't use it to support scrolling horizontally. So why should we care? Realistically, you should try to minimize your use of list views. But if you're building a small, simple list, then it's okay. And you may be thinking to yourself, how can we get views like these from simple list views? And if list views are bad, then what should we do? List views seem very limiting and don't really allow for a lot of flexibility. For example, in a Facebook post, we have to account for the profile image, the username, the emoji reactions, the various action buttons like commenting, sharing, liking. So this employs more views than just a plain text, which is why we have to employ using RecyclerViews, which is our next view. So RecyclerViews are a more modern, flexible, and performant approach to displaying lists. So what exactly is a recycler view? So recycler views are used to represent a list of some sort in an app, very similarly to list views. The terminology is similar here as well, where you have these lists used to represent a piece of your data. I say piece as in to represent kind of the whole of something. For example, if you have something like a Facebook post, that's comprised of many individual pieces of data, like the username, what was posted, emoji reactions, the timestamp, but those still comprise a single post. Is ultimately what makes up a single cell in your recycler view. And so why exactly is it called a recycler view? Part of its name comes from the performance enhancements that it has over list views. So only the cells that are immediately visible to the user are actually what's created, as opposed to the list view, which can kind of give you a whole host of data that you don't actually want to see. So it's efficient in the sense that if you have certain cells that aren't visible to the user, they'll be hidden, and then they'll be rendered as they can become visible to the screen as you scroll up and down, or left and right if you want to have a recycling view that's horizontal. That's also another benefit of recycling views as opposed to list views. You can actually create them such that they go horizontal as opposed to only vertical like list views. So yeah, as hidden things are rendered to the view, it'll use old views that are no longer visible to create and build new views, hence why it's considered recycling, because recycling old views to create and build new views, which is why it's pretty cool. Here's a concrete example of a recycler view on, again, Eatery. We tend to use a lot of our apps as examples for things in this class, and here's Eatery. So this main view is a recycler view. So information about an eatery, like what's showcased here, requires much more complexity than just a simple text view, just a simple list view, and this data can't be encompassed by just a text view, hence we use a recycler view. In this case, the recycler view isn't too complex. It just uses like a few image views and then some text views alongside a card view, which is like a type of view group used to create a card-based layout. So you can use recycler views in a really flexible way to create things like this, or as I mentioned earlier, like you can use them to create a Facebook post. So you can kind of tailor it to what you need, and they're very highly customizable. So kind of how do you go about building a RecyclerView. It has many components, a lot of kind of boilerplate skeleton code you kind of have to put into, make it as you will to kind of build what a RecyclerView is, but they all kind of boil down to these 6 components. So first we have our data. So this is usually information from your backend plus some representative class in Kotlin. People usually call this class like a model. The data is like what we're building a list of. So, for example, we have all our Facebook posts. We want to condense that down to actually building different things in the recycler. So here's like an example of model class of like a Facebook post. You have like your username, your comments, your profile picture, your date posted, like the reaction emojis, and like the if it's private or not. And then you use these like different fields to then create um, the recycler view. Any questions? Okay, cool. And then you can use a layout. So the second component of our RecyclerView is the layout. So how do we want our cells to look like? We can craft custom layouts for our cells in our RecyclerViews to then showcase how we can get the RecyclerViews to appear. So here's an example of another one of our apps, volume. So here on the left is kind of like the layout, like the beginnings of a layout of volume, beginnings of a layout of the RecyclerView, and then here's kind of like what a single cell looks like. It has like an image view, it has like the text, a few texts, a few text views, and then each of these layouts are then used to build multiple different cells. The next component is a layout manager. So the layout manager positions items within the RecyclerView. You can use one of several predefined layout managers, or you can kind of implement your own custom layout manager. So here's just an example of what I mean by a layout manager. So you can specify how exactly you want to organize your cells of your RecyclerView. You can have like horizontal lists, like up and down. You can have vertical. You can have like a grid-like view if you're kind of working like maybe if you know the app Depop uses like the grid-like view to host like the images of things you can click on. You can have like staggered view with different sizes, or you can kind of employ like your own custom mixed view, like like the Instagram Explore page uses like a mixed view, or like the different cells are different sizes. Like I think they use like reels and like videos to make them more bigger to kind of bring more attention to them and make you click on them. So yeah. The next component is the adapter, which provides a binding from your app's dataset to the item views that are displayed within your recycle view. So the adapter knows how to associate each item you position in the recycle view to a specific location in the data source. The adapter also handles the rebinding of cells if you ever want to change the data. And then the last component is the ViewHolder. The ViewHolder just helps draw the UI for individual elements that we want to draw to the screen. The ViewHolder describes kind of like the view of a cell and the metadata about its place within the recycle. So yeah, now we'll kind of showcase. I guess. Do you guys have any questions before we move on? Okay, cool. Now we're going to showcase both of these views in action in Android Studio. Um, yeah.
Recording. Okay, so first of all, we're gonna do a demo on RecyclerView. It's more widely used, so we're gonna start from that, and it's also harder. Start from the hard part first. First thing first, the most importantly, you will go to Build Gradle. And then the module, like there's a Build Gradle for project, and there's another one for module. The module is the one that you import of the libraries. So you scroll to the bottom, and in the dependency section, you have to include this line in order for you to call the program with RecyclerView. So you don't have to memorize it, just whenever you need it, search online what's the dependency implementation thing that you need to copy over to here. Second of all, we'll go to the layout. I have already created a RecyclerView component here. So when you do it, you can just like do RecyclerView, and then it's gonna autofill a lot of things for you. Instead of wrap content, I'm gonna say match parent. But you can change like the height and width to whatever that fits your need. And then I'm going back to the main activity. I get this RecyclerView programmatically, and next step I would do is to declare the LayoutManager. And the layout manager can take up to like, you can either leave it blank and then set up like each parameter for layout manager later, or you can have 3 parameter for this. The first one is this, it means like where the layout manager is wondering what is the context of like the recycle view. So this means like the context of the main activity. And the second one is whether or not you want the recycle view to be vertical or horizontal. So, or there's many options for this, but for demo purposes, I'm gonna set I'm gonna set a layout manager to make the recycler view to be vertical. And the last one is that if you want the recycle view to be reversed or not. And in this case, I don't want it to be reversed. Reverse means like whatever goes to like the bottom of the list will appear like to the top. But if you need it, you can make it too. Oh wait, the first part should also be a linear layout manager. And then I'm gonna pass on this layout manager to the recycler view. Second of all, we're gonna create a array list that contains all of the informations you might need for the recycler view. I'm gonna start it off creating an array list of strings. And I'm just gonna add some random data into it. Grapes. What's the next? I'll add a third one. Apple. And now it comes to the most important part is to creating, also the hardest part, is to create an adapter for the recycle view. I'm gonna name it my adapter. And now it's marked red because I haven't customized it. Oh, wait. I'm gonna create a new class to contain the adapter because there's gonna be a lot of things in it. Did I spell it wrong? Let me do that again. Right. Sorry. And the nice thing about Android Studio is it will ask you to implement the unimplemented function. So here comes the hard part. So there's like actually four functions you need to implement inside the adapter. First one first, you actually have to have a customized view holder, which is not provided with like Android Studio, but this is how it goes. So over here inside of RecyclerView view holder, we're gonna have instead my adapter view holder, which is the view holder that I just created. Okay, so inside the view holder, you will be assigning each of like, so we're gonna create a layout that contains how each of your items in the recycler are gonna look like. So the view holder is gonna find view by ID and then correspond all of the components inside that specific customized layout to the code. So we're gonna create a layout to your customize like each of the item. Gonna call it RecyclerView item. Since we only have like a bunch of fruit in this case, I'm just gonna use a text view to include in each of the items. But generally for RecyclerView, you will have more complicated designs, such as you can have image, you can have like even buttons, checkbox, a lot of things. If you just have like fruit, only string values, probably use ListView is a better idea. We're gonna be doing that too after the RecyclerView demo. Okay, so inside the view holder, we're gonna we're gonna find the component in the same way that you will be doing inside like a main activity. I forgot to give it Android. And in the uncreate view holder, you will be kind of correspond the recycler view to the whole layout. So inside the view holder, we correspond whatever component is inside of it to the recycler view. But inside uncreate view holder, we're gonna correspond the whole layout to the recycler view. So we achieve that by a thing called layout inflator. So the layout inflator takes a parameter of the context. Parent.context is actually asking the adopter what is like the overall context of the recycle view, which is actually calling to the main activity. So basically we use layout inflator to inflate whatever that's included in this customized view that you create, item view you create. Um, the last the last parameter does not matter, like you don't need to worry about it, it's generally false. But for the first parameter, it's gonna be where you put where you specify which customized layout you're gonna use. So this r.layout, whatever come after it is gonna correspond with the file name for the item view that you created. And then we're just gonna return the view group containing the view that I just got. Okay, now you have a recycler view with the items and with the components that you created. You wanna give the view some data. So this is when you're gonna give the view some data, you're gonna go to the third function inside the adapter. It's onBind ViewHolder. This is where you pass in the data. So you can just say holder, which is currently this holder here, and then .text view .text equals to data set, which is declared here. Oh, wait. Huh. Yeah, I have to set a I have to say it's a value passed in. And in this way, it's gonna look into all the array list that you passing, and then it's gonna give each of the items its value corresponding to its position. Last but not least, this is the simplest part. It's just asking how many items do you have inside the whole recycle view. It's basically asking how many, how long is the array list basically. So this is what you're gonna return. That's pretty intuitive. Okay, now we're going back. Actually, I'm gonna. Oh wait. Forgot to make it public. It's not supposed to be private. It's public. Sorry. Because it was private because like Android Studio default wanting me to write all of those adapter inside the same file, like an in-class file. But yeah, now I think it's a better coding style to start a whole new file for this. So this is how to create a kind of a simple recycle view. I'm gonna make sure it works. And wait a second. Oh, ah, wait a second. Did I import the wrong? Wait, did I import the wrong version of this? Can you check? Wait, can you check what's the version for this?
It's
Oh, 1.0. I think it's still not the newest version. Oh, change it to that. Okay, yeah, sorry. This is the here. This is the newest version. Follow along of making the recycler if you can, and let me know if there's anything that does not work as intended. I have grape, I have mango, I have apple. The reason why it's so large is I made the height match parent. I'm gonna make it not match parent, but if I do wrap content, the list is not gonna make it long enough for it to scroll. So that's why I make it match parent so you can see like the scrolling effect. Okay, but yeah, if it's just like, wait a second. Huh. And wait, why is it still scrollable? Oh, because I should not make this whole thing. Did I accidentally delete something? Second. Let's just say hide this wrap content. Okay, now we just have three tiny view here, but like feel free to like set whatever height you need and add more components. And I'm gonna briefly go over how to do a list view. It's pretty similar to how you guys implemented. Oh, first of all, any question for RecyclerView? Like how it works? Does it work for you guys? If you guys are following along. No question? You're good? Okay, all good. So if you guys have been in the lecture for spinners, um, ListView is very similar to spinners in general, like the way that it's getting implemented. I'm gonna be lazy, just changing the name here. And ListView does not require any extra like packages or libraries. Okay. Actually, I'm gonna uncomment the array list because we're still gonna use it. So basically, ListView requires an array adapter. If you recall from Spinner, that's the same thing that we're using. So what I will be doing is making an array adapter. If you recall, it takes also three values, but all three values are important. The first one is the context. The second one is whatever you want each of the items of the list view to look like. In this case, you can still make your own and put it in here. Like you can just do R layout, what I just created. But you can also use like the Android default. I have been using the Android default in the past lectures, but in this case, I will just use something that I just created. I'm gonna say M dataset. Oh, I think, oh, for a customized one, you actually have to, maybe you have to still use maybe you have to still write your own array adapter. Okay, yeah, I think it's better to use the default one from Android for this. Right. If you have to use like if you have to customize a adapter, probably just use the default. Like just use the RecyclerView. If not, use the default from Android. And the last step that's needed is, wait, should not call this ListView. I should call it adapter. ListView.adapter equals to, okay. Wait. Huh? Oh, what? Mm, sorry. Think.
Right, I was gonna, yeah, simple list. Yeah.
Sorry, simple list item is the one you should be using. I picked the wrong customize. You can go to like Android Studio's documentation to see what each of those default layout look like. Okay, yeah, now we have a list view looking like this. I'm also gonna quickly show how to create data class. So you go to a Java file, Java folder, and then you do a right click, new, where's, wait, colon class, and then there's data class. Let's say if I want to create a data class, student is gonna automatically generate this for me. And then I can say student has ID. Student might also have a name. Student also have their favorite color. Wait, I don't know how to spell favorite color. Also could be a string. And this is really helpful when you're creating RecyclerView because most of the time you would not have an array list of simply a string. So you might be able to have array list of students, and inside the student you can, like inside the array list you can do like, give me, this is my ID. What's my name? My name is Jessie, and wait, actually ID has to be int. And my favorite color is purple. And when you're passing this to, let's say, RecyclerView adapter, all you need to do is change the type of array list here, and you can have a lot of component here. For example, you can have a text view that represent the favorite color. You have a text view representing the student's name, and over here, do we have? Okay, I actually might have enough time to demo this. I will uncomment this. I'm gonna call it ListView, but you guys know it's a RecyclerView actually. Yeah. it's a recycler that has a name ListView. And inside the view group item, I can have another text view. Let's just call it text view color. Actually, text view name. And let's make it constrained to the bottom of parent. Text view color. Let's just find my view by ID for the text view color. Actually, oh, name. Sorry about that. So you realize that this is gonna say, so text view, I'm gonna have text view text equals to the ID of students. But since it's integer, let's just say toString. And I'm gonna have text view name equals to student's name. And I'm gonna have multiple Jesse because I don't have time to think about other things. Oh, okay, they're collapsing together, huh? Yeah, that's mainly because I have to maybe change I have to change like, I guess this layout a little bit. Right. Margin, like, I guess margin bottom. Actually, do you know, I can just like margin top to the bottom of the text view. Yes, nice catch. Sorry about that. Yes, now we have a bunch of Jesse with ID equals to, and you can even make this like maybe hex code, and then assign like the text view a color or something like that. There's a lot of things you can do about it. But yeah, this is RecyclerView. And do you guys have any questions? Okay, that's all for today. Homework? Okay. Not in recitation.
I mean,
Sure.